In the previous video, we saw deadlock prevention. It is one of the 4 methods. Now we will see the remaining 3 methods. Deadlock avoidance. Deadlock avoidance can be done with Banker's algorithm. It involves maintaining a set of data using which decision is made whether to entertain the new request or not. If entertaining new request causes system to move in an unsafe state, then it is discarded. Unsafe state means occurring of deadlock. If it is, suppose we'll have all the details of the processes, like what number of resources it has, what new it wants, and what are the available resources. So with all this data, a decision is made. If suppose a process requests some resources, then we'll, based on the data available, then we'll see whether a deadlock will occur if we allocate the resources based on the request. If deadlock does not occur even after allocating the resources, then we'll give the resources to the process. If deadlock occurs, then we won't give. So this strategy requires that every process declares its maximum requirement of each resource type in the beginning. So as I told you, in the beginning itself, we'll keep all the data required, all the data. So we should declare, each process should declare its maximum requirement of each process in the beginning itself. So the difficulty with this process is we need to predict requirement of processes before execution itself. That is the challenge with the deadlock avoidance. Next, another method, deadlock detection and recovery. It involves waiting until a deadlock occurs. After deadlock occurs, system state is recovered. Recovery can be done in 3 ways. Preempting resources, terminating one or more processes involved in deadlock. If we terminate, then recovery automatically happens, right? By deadlock avoiding. Allow users to take manual intervention and inform system operator. So these are the 3 ways in which system state can be recovered. So the difficulty with this approach is detecting the deadlock. So in the name itself, we saw. First we need to detect the deadlock, then recovery happens. So the challenge with this is detecting the deadlock before itself. After recovery happens, this is one of the method. The last method is deadlock ignorance. So this method is also known as ostrich approach. It involves ignoring concept of deadlock and assuming as if it does not exist. In this method, we forget that deadlock itself exists. It helps to avoid extra overload of handling deadlock. So we are ignoring the concept itself. So it helps us to avoid extra overload of handling deadlock. Windows and Linux use this strategy. So we have operating systems, Windows and Linux. Both these operating systems use this strategy, deadlock ignorance. So in the previous video and this video, we have seen all the 4 methods for handling deadlocks. I hope you understood complete picture about deadlock, why it occurs, what are the conditions required for occurrence of deadlock, and what are the methods we use to handle those deadlocks. Thank you.